Close your eyes and picture this. A shadow darker than storm clouds crossing overhead. You look up, heart pounding, as a creature larger than a giraffe glides silently above. Its wingspan stretches wider than a school bus, blocking out the sun with leathery wings. This isn't science fiction. This was reality 70 million years ago when Earth belonged to flying monsters. Today, our largest airborne animals barely tip the scales at 45 pounds, their wingspans modest. But prehistoric skies told a different story, one written in bone and fossilized terror. These weren't birds or dinosaurs, but something far stranger. Pterosaurs, reptilian titans defying every law of flight. Their reign lasted 160 million years, and their story will change how you see the sky forever. The impossible made real. Imagine standing on a Cretaceous shoreline as wind whips across ancient waters. The air feels different here, thicker, richer in oxygen than our modern atmosphere. Suddenly, the horizon darkens. Something massive approaches, riding invisible currents with effortless grace. This is Quetzalcoatlus, named after the Aztec feathered serpent god of wind and sky. With a 36-foot wingspan, it remains one of history's largest flying creatures ever discovered. Its very existence challenges everything we think we know about the physics of flight. Weighing up to 550 pounds, Quetzalcoatlus possessed bones as thin as parchment, yet stronger than steel. Evolution had engineered a masterpiece. Pneumatic bones filled with air pockets, reducing weight without sacrificing strength. Every gram mattered when defying gravity at such colossal scale. But here's where the story gets truly fascinating. How did something this massive even take off? Modern birds push off with powerful legs, launching themselves skyward through sheer muscular force. Quetzalcoatlus couldn't rely on legs alone. Its body was simply too large, too heavy. Scientists now believe it used all four limbs in a coordinated vault, essentially pole vaulting into flight. Picture a creature the size of a small airplane crouching low, then explosively launching upward. Its wings would snap open mid-leap, catching air with a thunderous crack audible for miles. Once airborne, Quetzalcoatlus transformed into something almost supernatural, a living glider riding thermals for hours. Some researchers suggest it could remain aloft for days, crossing entire continents without landing. Its neck stretched longer than a human is tall, supporting a skull exceeding 6 feet. This giraffe-like neck served multiple purposes beyond just looking terrifying to ground-dwelling dinosaurs below. In coastal regions, Quetzalcoatlus likely fished like modern herons, stabbing downward with surgical precision. Inland, it may have hunted terrestrial prey, using its massive beak like a spear. Fossil evidence from 1970s Texas revealed a creature that shouldn't exist by conventional understanding. Each new discovery adds layers to an already complex mystery, deepening our fascination. Quetzalcoatlus wasn't just large. It was a biological impossibility that somehow thrived for millions of years. The Terrestrial Titan. But Quetzalcoatlus wasn't alone in pushing evolutionary boundaries to their absolute breaking point. On ancient islands where modern Romania now sits, an even more formidable predator stalked the earth. Meet Hatzegopteryx, possibly the heaviest flying animal ever to exist, weighing between 500 and 660 pounds. Unlike its lighter cousin, Hatzegopteryx wasn't built for endless soaring across open skies and distant horizons. Its bones were dense, robust, engineered to withstand impacts that would shatter more delicate pterosaur skeletons. This was a creature designed for brutality, not grace, power over elegance in every aspect. The late Cretaceous islands of Hatzeg hosted a bizarre ecosystem unlike anywhere else on Earth. Isolation had triggered evolutionary experiments. Dinosaurs that were giants elsewhere became dwarfs here, shrinking across generations. But Hatzegopteryx took the opposite path, becoming a titan among pygmies, the apex predator. Here's what makes this creature truly extraordinary. It spent most of its life on the ground. With such massive weight, flight required perfect conditions, favorable winds, and considerable energy expenditure beforehand. Hatzegopteryx walked the earth like a nightmare made flesh, wings folded against its body. Its neck was short but incredibly thick, supporting a skull over 6 feet long and wide. This anatomy tells a chilling story. Hatzegopteryx was a terrestrial super predator, hunting juvenile dinosaurs and reptiles. Its jaws could deliver devastating bites, seizing prey with bone-crushing force before swallowing chunks whole. Imagine encountering this creature on a misty Cretaceous morning as fog rolls across volcanic islands. You'd see a silhouette taller than a bear, moving with deliberate, predatory intent through prehistoric forests. When threatened or hunting, it could launch skyward, transforming from ground hunter to aerial nightmare. On islands where resources were scarce and competition fierce, strength meant survival above all else. Hatzegopteryx embodied that principle perfectly, a living testament to evolution's creative brutality when circumstances demanded. Masters of the southern skies. While northern continents hosted their own aerial giants, the ancient supercontinent Gondwana told different stories. In what is now northeastern Brazil, limestone deposits preserve one of Earth's most spectacular fossil records. Here, pterosaurs evolved into forms both beautiful and bizarre, perfectly adapted to tropical paradise. Tropeognathus mesembryanus ruled these skies 110 million years ago with a 28-foot wingspan and distinctive features. Its name means keeled jaw, referring to prominent bony crests running along both upper and lower jaws. These structures weren't just decorative. They served crucial aerodynamic functions during high-speed fishing runs over water. Weighing approximately 440 pounds, Tropeognathus combined size with efficiency in ways that still astound modern scientists. Its hollow bones and streamlined body allowed sustained flight over vast distances, patrolling coastlines for hours. Sharp teeth projected forward like spears, perfectly designed for snatching fish from shallow Cretaceous seas. The Santana Formation, where these fossils were discovered, offers an unparalleled window into ancient life. Chemical conditions in these prehistoric lakes enabled rapid fossilization, preserving delicate bones and even soft tissue. Every discovery adds detail to our understanding of how these creatures lived, hunted, and died. But Tropeognathus wasn't alone in these skies. It shared airspace with equally impressive relatives and competitors. Thalassodromeus sethi possessed one of the most bizarre features ever evolved, a cranial crest extending beyond. This massive structure, longer than the animal's face, defied all conventional evolutionary logic and practical sense. Scientists debate its purpose endlessly. Was it for sexual display, thermoregulation, or social signaling among groups? Perhaps all three, serving multiple functions simultaneously, as evolution often favors efficiency over single-purpose adaptations. The crest may have blazed with vivid colors, turning each individual into a flying billboard. Like Quetzalcoatlus, it catapulted skyward, then caught thermals for long distance, soaring across ancient Gondwana. Its lifestyle mirrored modern albatrosses, endless wandering, riding winds, conserving energy through masterful gliding techniques. The fishermen of lost oceans. As we journey through time, we encounter pterosaurs that specialized in exploiting Earth's ancient oceans. Pteranodon longiceps soared above the Western Interior Seaway 85 million years ago when North America. This shallow sea split the continent in two, creating perfect hunting grounds for aerial predators. With a 24-foot wingspan, but weighing only 55 pounds, Pteranodon achieved remarkable efficiency in flight. Its body was a study in weight reduction. Every bone hollowed, every structure optimized. This allowed hours of effortless gliding, searching for fish schools rippling beneath crystal-clear Cretaceous waters. The cranial crest of Pteranodon remains one of paleontology's most intriguing mysteries even after decades. In males, this structure extended backward in a long projection, sometimes exceeding the skull's length. Was it for aerodynamics, sexual display, or species recognition? Likely all three purposes combined. Sexual dimorphism was pronounced. Males were larger with more elaborate crests, suggesting competitive displays for mates. Females possessed smaller, more practical crests, prioritizing flight efficiency over visual spectacle during breeding seasons. This pattern mirrors many modern birds where males advertise genetic fitness through exaggerated features. Pteranodon's hunting strategy was elegant in its simplicity. Glide low over water, spot movement below. Its sharp beak would dip precisely, snatching fish without breaking flight rhythm or losing precious altitude. This technique required extraordinary coordination between vision, timing, and aerial maneuvering at high speeds. Fossils from Kansas's Niobrara Formation reveal an animal perfectly adapted to coastal life, but awkward on land. Small hind legs suggest Pteranodon rarely walked, instead launching directly from cliffs or water surfaces. Once airborne, it became grace incarnate, but grounded, it was vulnerable and clumsy. The enigmatic night glider. Not all pterosaurs were giants. Some achieved success through specialization rather than sheer, overwhelming size. Nyctosaurus gracilis, the slender night lizard, possessed one of evolution's most puzzling adaptations ever documented. Its cranial crest formed an inverted Y shape, projecting vertically in a structure that seems impossible. With an 8-foot wingspan, Nyctosaurus was modest compared to its larger relatives soaring the same skies. But what it lacked in size, it compensated through precision, agility, and mysterious adaptations. Its toothless beak was slender and pointed, perfect for snatching small fish and cephalopods mid-flight. The lack of teeth wasn't a disadvantage, but rather an evolutionary refinement towards specialized aerial fishing. Like modern frigate birds, Nyctosaurus could snatch prey from the surface without fully submerging or losing momentum. This technique required split-second timing and extraordinary visual acuity in challenging conditions over open water. Its bizarre crest challenges functional explanation even today, with theories ranging from sexual ornament to sail. Some scientists suggest it supported a membrane, creating a biological sail for enhanced maneuverability. Others argue it was purely for display, turning each individual into a flying flag. Fossils from the Niobrara Formation preserve these delicate creatures in remarkable detail despite their fragility. Each specimen offers glimpses into behavior, ecology, and the incredible diversity pterosaurs achieved across millions. Nyctosaurus represents evolution's willingness to experiment with forms that seem impractical yet somehow worked perfectly. The pioneers. Our journey through pterosaur evolution wouldn't be complete without visiting the pioneers, the early experimenters. Dimorphodon, living 195 million years ago during the early Jurassic, represents a crucial evolutionary link. But this ungainly appearance masked a versatile predator adapted for both flight and terrestrial hunting. Its skull was massive, equipped with two distinct tooth types for different feeding purposes. Long, pointed front teeth grabbed prey firmly, while smaller rear teeth crushed or processed food. This versatility allowed Dimorphodon to exploit multiple food sources: insects, small vertebrates, fish, whatever opportunity presented. In a world still finding its ecological balance, adaptability meant survival above all else. Unlike later pterosaurs specialized for soaring, Dimorphodon flew in short, powerful bursts between perches. Its heavy body and short wings weren't designed for marathon flights across continents. Instead, it excelled at quick movements, escaping predators, and surprising prey in dense Jurassic forests. On the ground, Dimorphodon moved with surprising agility, walking either bipedally or on all fours.